There are several terms and concepts that are essential when planning an effective irrigation system. The first is water pressure. It's measured in pounds per square inch, or PSI. It's the amount of force that the water on your property will exert. Knowing your property's available water pressure will be a factor when calculating how many sprinkler heads can be operating at the same time and still be effective. If the PSI for your yard is low, fewer sprinklers may efficiently operate at the same time. If the PSI is too high, that also will have an adverse effect on the sprinkler's performance. Another measurement that is critical in the design of your system is the amount of water, or flow, that is available through your supply line. This is measured as gallons per minute, or GPM. A third factor in the design equation is the actual sprinkler nozzle size, which affects the amount of water passing through. On these rotor nozzles, a GPM rating is stamped right on them, but this provides only a general idea of their performance. To determine the actual GPM of a nozzle, refer to its performance chart, which factors in your system's pressure to more accurately predict the amount of precipitation it will emit. On the other hand, these fixed spray nozzles are labeled with a number that provides a general idea of their radius of throw. Again, refer to their performance chart to more accurately determine their distance of throw and GPM performance. The finished design will require a balance of your property's available water pressure and flow with the type, size, and number of sprinkler heads to be used at any one time. If, for example, you needed 12 sprinkler heads to cover a particular area of your yard, but there wasn't enough water pressure and flow to support 12 heads operating at the same time, you would divide the area into 2 sections, each with 6 sprinklers, and schedule one to run after the other. In order to control these 2 groups of sprinklers independently, each must be connected to their own valve. This arrangement is known as a valve zone. In addition to this example, there are several other reasons for designating a specific area as a valve zone. One is related to the type of plant material growing there. A typical yard will have different areas made up of lawn, flowers, shrubs, and trees, and the amount of water needed to keep these plants healthy varies. By making each area a separate zone, you then have the flexibility to adjust irrigation times and methods to match the specific plant material. Other good reasons for using valve zones would include addressing the needs of an area that is primarily in direct sunlight or mostly in shade. A separate zone would be appropriate for watering a slope or as a way to address runoff on hard soils like clay. Zones are also important to optimize sprinkler performance. The rule is, always use the same type of sprinklers in any valve zone. Keep sprays with sprays, rotors with rotors, and drip irrigation with drip. As a matter of efficiency, it's better to group several valves together, assigned to a common area, such as the front or backyard, for example. This arrangement is known as a valve manifold. Each valve is still connected to its own group of sprinklers, but it takes less pipe and other materials if several are located in one valve box. Choosing the best sprinkler for a particular application is determined by the plant material and the characteristics of the area to be irrigated. But whatever the choice of sprinkler device, the standard sprinkler head should be positioned so that its spray reaches all the way to the next. This overlapping pattern design is called head-to-head spacing and assures complete water coverage of the area. Also, selecting a location for the controller is important. It should be convenient and near a power source. Many homeowners choose the garage.